let's try another one of these hypothesis tests for the difference between two sample means, or between two means using large independent samples. So in this case, someone wants to know, does the new assembly line increase the heart rate of the people on the assembly line? So maybe they got a new assembly line and they're wondering if maybe the assembly line is more stressful, and does it increase the heart rates of the employees? Okay, so I'll call this mu1 and this mu2, and I want to know, does the new line, is the mean for that one bigger than the mean for the old line? So this is going to be a greater than sign. That's going to make this a right-tailed test, and these will each have a 1 and these will each have a 2. And so the null hypothesis is going to say that nope, there's no difference between the two. Mu1 is equal to mu2. They're the same. And then I want to show, no, I think that mu1 is greater than mu2. Okay, and that makes this a right-tailed test. Notice the less than or greater than sign depends on how this table is arranged. If this were the old line and this one were the new line, then it would be a less than sign. So it doesn't depend upon this. It depends on which group you call mu1 and which one you call mu2. And in this case, I just happen to want to show mu1 as being bigger than mu2. So that would make this a right-tailed test. And I'm going to do this at mu equals 0.01. And I'm going to shade the right tail. So I'm going to go to my table. I'm going to do one-tailed alpha, 0.01. My critical Z value is 2.326. So this is 2.326. And this over here would be the reject H0. So it has to be greater than that in order to reject H0. So now, putting things in for my test statistic, it's the difference between the two sample means. Okay, it's that difference minus the hypothesized difference. And then the standard deviation of the first group squared over the number in the first group. The standard deviation over the second group squared over the number in the second group. And then you're going to take the square root of that. So putting this in our calculator, I get 78.4 minus 71.6. Okay, hit equals, and minus 0 wouldn't change anything. And then underneath the radical, all in parentheses, I get 14.6 squared over 30 plus 12.3 squared over 30. And that is equal to 1.95. And that's my test statistic. Now that actually does not lie in the rejection region. So I'm going to fail to reject H0. And that means there is not enough evidence to conclude the new line has a greater mean heart rate. Okay, so this is at the 0.01 significance level. So if I would have performed this at the 0.05 significance level, then I would have had enough evidence. It would be over the 1.645, so you would have rejected. So if, let's say, this test was done because employees were complaining about the new line being more stressful, then they could have very well have chosen a more significant significance level in order to make it seem as if the new mean heart rate hasn't increased. What this actually means here, since you would reject it at the 0.05 significance level, does mean that there actually has been an increase, but maybe it hasn't been that significant of an increase. So, and at the 0.01 significance level, we could say that the increase is not statistically significant, though at the 0.05 significance level, it would be statistically significant. And so, those are just things to keep in mind as you think about interpreting the test. So, okay, on this last one, I'm going to have you try it first, and then you can play the video and see how you do.